So in this unit for radicals, there's something that's very important for you to know, which is perfect square values. Perfect squares are an integer that results from squaring another integer. When you take a perfect square value, or you take the square root of a perfect square value, you're going to get these whole numbers right here. So all of these numbers here on the side are going to be, so 1, 4, 9, 16, all the way through. These numbers are going to be perfect square values. So for example, if you have the square root of 4, you end up getting 2 as your answer. So the square root of 4 is 2, same as 2 squared equals 4. Same with the square root of 225, you're going to get the number 15 because 15 squared is 225. So that's something to remember. These values on the right are what's going to be used to help you simplify the square root. Now, some of the definitions that you need to know, one of them is the radicand. That is the number that's underneath the radical sign. So for example, this right here is the radicand. So that is what we're looking to simplify when it comes down to simplifying radicals. Now, here's the steps that you're going to use. You're going to check if the radicand is a perfect square number. If it is, you're just going to take that perfect square and it's going to be a whole number. If it's not, you're going to move on to the second step, which it says start with the highest perfect square number that divides the radicand evenly. So we have to think about, we're going to have to use that chart, and that's going to help you. So I would definitely suggest writing that chart down. That chart is going to help you all the perfect square values to simplify. Once you find the highest perfect square value, you're going to take the square root of the perfect square number. That's going to go on the outside of the radical, and you're going to leave the other number underneath the radical. So I will show you some examples, but first, before I do that, something that's very, very important is that you cannot take the square root of a negative number. So for example, if you have the square root of -4, there's no possible way that you could have a number times itself to get you a negative value. So that's why your final answer for this one is that it can't be simplified. So anytime you see a negative underneath the square root, there is no possible way, so it can't be simplified. Okay, we're going to start off with our first example. Okay, so we have the square root of 196. Now with this one actually is a perfect square value. This one is 14 squared is going to give you 196. So if I take the square root of 196, my answer is 14. This is because this value underneath is a perfect square. Okay. Now, we have the square root of -25. With that being the square root of a negative number, that answer, even though this 25 is a perfect square value, this is actually going to can't be simplified because you can never have a number underneath a radical being negative when you're dealing with square roots. Now for number 28, or for example 3, with the square root of 28, you're going to think about, okay, what's the greatest perfect square value that I can take out? So what I'm going to do is I'm going to kind of run through my list of my perfect square values. You don't ever have to start with 1, but I'm going to say to myself, okay, 4 is the next perfect square value on that list. Does that work? Can I take that out of 28? It does. If I go further and I look at my list, 9, that doesn't work. Like 28 divided by 9, that doesn't work. 28 divided by 16, that doesn't work. 28 divided by 25, that's not going to work. So my highest perfect square value is that 4 times 7. What I'm going to do is I'm going to take the square root of 4, which is 2. I'm going to put that on the outside. And then I'm going to keep the square root of 7 on the inside. So my final answer is going to be 2 times the square root of 7. Okay, this one, I'm going to look at the square root of 72, and I'm going to see if I can simplify. It's not a perfect square value, so I'm going to move on to the next step, and I'm going to simplify. I'm going to kind of run through. So 72 divided by 4, 72 divided by 9. Oh, that works. 72 divided by 9. 72 divided by 16. 72 divided by 25. I want to kind of see 72 divided by 36. That is probably going to be our highest value. So I'm going to take the square root of 36 times the square root of 2. I'm going to take the square root of 36, which is 6, and leave that square root of 2 underneath. So that is going to be my perfect square. That's going to be my answer. And it's going to be 6 times the square root of 2. Okay, this one, I'm going to try to have to find my greatest perfect square value. So you can go through that list and just do like 486 divided by 4, 486 divided by 9, kind of go through. Something you have to be careful about is that even though there's a negative here, you can still take the square root of this because it's going to be -1 and it's times that square root value. So I'm going to try to find the values with the highest. My highest value is actually going to be 81 times the square root of 6. So 81 times 6 gives me 486. So 81 is actually going to be my highest value. So what I'm going to do is I'm going to take the square root of 81. I'm going to bring this down, which is 9, times the square root of 6. -1 times 9 is -9. Square root 6. That's going to be my final answer. Okay, same thing here. This is saying 7 times the square root of 50. I have to figure out what's going to be my greatest perfect square value I can take out, and that's going to be the square root of 25 times the square root of 2. I'm going to take 7 times square root of 25 is 5 times the square root of 2. So this is going to be 35 square root 2. Okay, with this one, you now see it has this fraction underneath the square root. So what's going to happen is you're going to see first if you can simplify in here first. If you can't, then you're just going to take the square root of the top and the square root of the bottom. So I'm going to get 11 over 7, and that's going to be my final answer because square root of 21 is a perfect square and square root of 49 is a perfect square. So I have 11 divided by 7. Now here, I'm going to look. 2 and 32 I can actually simplify, so I'm going to do that first. They both have 2 in common, so I'm going to simplify. Then I'm going to take the square root of the top and a square root of the bottom. So square root of 1 is 1. Square root of 16 is 4. So my final answer is 1/4. This one I have to be careful because I have this 3 on the outside and it's being multiplied. So I can't simplify anything in there. So it's 3 times, and it's the square root of 5 over the square root of 9. So this is going to become 3. I can't do anything with the square root of 5, so I'm going to leave it. Square root of 9 is 3. And then you always want to check to see if you can simplify these numbers on the outside if they're divisible. So 3 divided by 3 gives me 1. So your final answer is going to be square root of 5. My last example, I'm going to see, can I simplify underneath first? I can't, so I'm going to take the square root of 40 and the square root of 81. Right now, the square root of 81 is 9. The thing I have to look for as well is see if I could simplify this top and break it down. So can I break down or take out the greatest perfect square value here. I can, so my two values are 4 and 10, 4 being a perfect square value over 9. I'm going to have 2 square root 10 over 9. I want to look to see if I can simplify 2 and 9. I can't, so that's going to be my final answer.